Even in the Cartesian form plus in cylindrical form of grid system, some exercise are remaining. So first we are trying to cover that. Then we will move to the third option of preparing the grid lines in the software is of exporting and importing method. Okay, so in the last session we also have seen in under which situation you have to choose a particular type of method, either when you have to go with the ETABS quick template option, or either you have to go with the export and import method. So it's all depends on your architectural plan or in plan geometry of your building. So if your building or architecture plan or geometry of the structure is simple, so in that way what you can proceed with the ETABS quick template option. And if your geometry is not much easy, it's so much complicated, in that case you have to proceed with export and import method. Got it? So first tell me, sorry, let me show you. So actually we have to start this cylindrical grid. We have to form this cylindrical grid in the ETABS software. So basically I'm going to open this ETABS software. Good. Now next, go to file and go to new model. Once you click over the new model, you know that a new dialog box will open as a model initialization. You all know all these things. Just go with third option. Here the most important thing you have to decide as what is the unit system, what is the unit, whether it is your plan in feet and inches or whether it is in metric SI, what the system. So let's see, here the system is what the values are given in meter 4. Okay, so it is what in metric system we have to proceed. So I'm going to take metric SI and still section database, still design code, concrete design code. This you have to choose as per your country means code. Okay, so let's say simply okay. Once you click over the OK, it will take you to all to this new option of defining the grids. In plan grids and overhead definition you have to set here. But as you can see here, there is no any option to create the cylindrical grid. Here there is no option of creating the cylindrical grid. Like if you are going to see here, so here the radial direction for this kind, this I'm going to call it as what, tangential line, and this is what your radial direction. So over the radial direction, how many grids will be? 1 2 3 4 5, and these lines are these purple, or I can say pink color lines, are actually your tangential lines, and this color is what your in radial direction. Along x direction it is what radial, and over this curve this is what are the tangential lines. So that kind of provision and that kind of definition is not possible to define here. Then what, how you can prepare that kind of cylindrical grid? So there is no option to make a choice of cylindrical or to make a choice of Cartesian. Then what? So very simple, you have to go with the blank. How to proceed for that kind of grids, try to understand. First click on the blank and let's say simply OK. Once you click over the OK, as usual it will take you all inside of the software. Now close this model explorer and two windows will be there, as we have taken the means blank option, so nothing will be there. So basically what you need to do, go to editor and go to edit stories and grid system. Once you click over that, okay, so it is what over the height data, over the height information is available here, over the height definition is available here, but we don't need to bother about these what definitions are there. We need to concentrate only in plan definition. But you know that actually you may ask a question, we have not defined any grids, so why this grid system is there? So yeah, one grid system will always be there as G1. Okay, now here means without of concentrating to this G1, we are going to add a more new grid system. We have to here put as a new grid system. So I am going to click here as what, add a new grid system. Once you click or add a new grid system, so now here it is asking what grid label you want to give for a new grid system. So yeah, previous one by default one G1 is there. I am going to add one more grid system there as G2. So yeah, it is the G2. Now option you are getting what? Either you can proceed for the Cartesian one, or either you want to proceed for the cylindrical one. So you know very well we have to go for the cylindrical, check this cylindrical option. Very simple. Next, radial. So it is what? The labeling. It is what about the labeling? How the labeling the software is by default is giving to the your grids. So first grid label is A. Go back. Accordingly, I have prepared this drawing. So basically the grid, as I told you, along x direction, it is what? Radial. This curve is radial. This what is the radial? This is what? Radial. So this is what A center, then B, then C. Half part we are considering only. So A, B, C. So labeling is starting from A, from the center, and the labeling is moving towards end of the this axis, away from the center actually. So I'm going to look at the ETABS. ETABS is what actually doing. So first grid label as A, that will be at the center, labeling direction away from the center. See, away from the center. So at the center will be A, B, C, D, E, F, like that. So go back to your software. Here it is what? A. If you would like to change it to what? Toward the center, you can do that. So the labeling will be what? It will be here instead of F, there will be what? A. Then here it will be what? B, C, D, E, and at the center you will get what? F. Okay, so like that the things will be. But yeah, I'm not going to change the default setting. I would like to keep it as it is. But in future, if you are dealing any kind of project and like so many grid systems, there you have to define, and there will be what? Clashing of the labels. In that way you can change it. So the option the software has given, the discussion of this thing is what the option has given. In any situation, if you feel you want to change it, okay, so you can do that. Similarly, in tangential direction, the numbering is given as 1, 2, 3, 4. Okay, numbering is there. So it is what? From clockwise direction or counterclock, means anti-clock. In our language, what we are saying that clockwise direction like this, and in this direction we are calling it as anti-clock. So software what calling here? Clock means let me show you, clockwise and counterclockwise. Got it? So means clockwise and anti-clockwise. So by default clockwise labeling is there, so let it to be. If you would like to change it, you can change that. Okay, so I'm going to work with the clockwise. So this is all done labeling. Now it is asking about position of your origin of the cylindrical grid. It is asking about what? Positioning and orientation, sorry, the rotation of your center of your grid. So basically what it is asking, suppose this is what? 0, 0. This is what? 0, 0. This is what? Global axis center origin. So if you are going to, if you are not going to put anything here, and if you are keeping it to be 0, 0, so your grid is going to be formed like this. Your grid is going to be formed like this. Okay, but if you are going to put the any distance like 5 meter, so in x direction it is going to be shifted like this, in x direction. If you are going to change it to what? 5 meter in this direction, 5 meter in this direction, so it is going to become what? Here suppose it is 0, 0, here it is 0, 0, so your grid is going to be modeled here. So here it is what? At the center 5 meter, and here it is what? It is the 5 meter. So like that this is what positioning. So right now we are not going to do anything, let it to be as it is. I will let you know later how you can edit this in the edit option after the completion of this grid. Now next, number of grid lines in radial direction. Number of grid lines in radial direction. Go back to your exercise and see. Number of grids is what? 1 at the center, second, third, fourth, fifth, and sixth. And that is actually written here. Number of grids in radial direction as 6 number. So I am going to put that here as in radial direction as number as 6. Next, number of grid lines in tangential direction. Number of grid lines in tangential direction. So let me see. In tangential direction, how you can decide number of grids in tangential direction? Very simple. Measure the total degree. Total degree from one end to another end. So it is what? 180. You know very well, 180 degree. If it is like this, so it will be what? 90 degree. If it is what? 275, 270 degree. What it will be? 180 plus 90. So like that. And if you want to build for the complete circle, it will be 360, like that. So basically what how many number of tangential lines are there that we need to calculate? So 180 divided by unit angle between the two tangential lines. So unit angle is what actually given here as 9 degree. So 9 plus 1, this is actually the formula that is written here. So 180 divided by 9 plus 1, that is going to become what? 21. So I am going to put here as 21. So just put it here as 21 number of grid lines in tangential direction. So it will be basically 21. Spacing of grids in radial direction, very simple. Spacing of grids. So spacing of grids in radial direction is what? 4 meter, 4 meter, 4 meter, 4 meter, 4 meter. Equal spacing, uniform spacings are there between each radial grids. So I am going to put here as 4. So put it as 4 meter. And now spacing of grids in tangential direction. So as you know that it is in degree. It is not in distance, or in linear distance is not there. So it is what? 9 degree. So I am going to put there, put here as 9. This is all done. You have to simply say okay. And once again you have to simply say okay. Once you click over the okay, so now your grids will be available here. Your grid system will be available here. So visibility is not much clear. It is what means very light grids are there. Actually that it is okay. But yeah, for your visibility, for your understanding, I am going to improve the visibility by increasing the dark I'm choosing some dark color. So go to edit grid system. Now see, previously there was only one grid as G1. Now here what? Grid 2 is also there. So I am going to check this grid 2. Just go to modify and show grid system. Once you click over the modify and go modify and edit grid system, see here. Now as usual the things are available that we are practicing. Okay, so just go to this and some dark color I would like to take, or change the color to red one, so it will be clearly visible. And let's say simply okay. Let's say simply okay. Let's say simply okay. So now see here it is what? Like this. Like this we have created our cylindrical grid system. That is what? Very simple. It is what? Very simple. Again like suppose you want to increase the bubble size, go to edit grid system and go to second one, go to modify and change it to what? Suppose I would like to have it as 1500. Let's say simply okay, 1500. Let's say okay. Okay, this is all done. Is that all clear? So in this way we have to prepare the cylindrical grid system in the ETABS software. Now it's your time. If you have any doubt and question, you can ask me fast.
Sir, please kindly repeat the second one, the last one you show us.
What you want to see again? Hello.
Just you modified the bubble.
Achha, okay, bubble sizes. Okay, go to editor. Everything you have to go for any kind of editing work. You need to go to edit. Go to edit stories and grid system. If you want to go to edit any thing over the height, you need to go this first section. If you want to edit anything in plan, so you need to go with this grid system. So second grid, go to modify and show grid system. Once you click over that, so suppose I would like to reduce it now. It is what? 1200. Change it to 1200. Suppose I would like to take the color of this blue color. I would like to take the blue color. Let's say simply okay. Let's say simply okay. Let's say okay. So now it is changed basically. Is that all okay?
Yes.
He's asking about what? If the grids if the spacing are non-uniform. If suppose in any situation when the spacing is non-uniform, suppose in radial direction spacing is what? Suppose the spacing is not uniform, is non-uniform. Okay, so suppose it is 5 meter, it is what? 2.5 meter, it is what? 3 meter, it is what? 4 meter, then it is what? 6 meter. So what's the problem? If suppose this is what your suppose it is 9 degree, it is what? Directly instead of 9 degree means 9 degree, it is going to become 18 degree, like that, then 9 degree, then 18 degree. So okay, first go with the uniform. Once the uniform gets completed, Then go to editor, go to edit grid system stories, and go with the second one, go to modify, and once you click over the modify, now here as usual grids will be available here. Go to display grid data as spacing. Now here you can do. So suppose the first one is what, 4 meters, second one is what, suppose 3 meters, suppose it is what, again 5 meters, suppose it is what it is what suppose 2 meter. Got it? And here it is what, 9, then it is what, 18, then here it is what, 9, then again 18, then here it is what, 9, then here it is what, 18. Okay, like that. Just come down, 18, then here 9 to 18, here 18, here 18, and what next, here it is what, 18, here it is what, 18, next here it is also 18, here it is what, next 18, and finally here it is what, 18, like that. Let's say simply okay. Once you click over the ok and then again click over the ok, so your geometry is totally going to be changed. Hello, actually we did the we did the calculation for 180 total angle, and accordingly we have given the dimension, but here we have changed it. So that's why accordingly it is what totally the things has been changed. Are you getting my point?
Yes,
Hello?
sir.
Yes, yes.
सर
Yes, sir.
सर ए ग्रिड कहाँ है सर इसमें?
एक ग्रिड आपका यहाँ पर है सेंटर पर, ए, दैट इज नॉट रिटर्न.
हाँ वो दिखाई नहीं दे रही ना सर.
हाँ वो नहीं दिखाई देगा आपको, वो लेबल ही नहीं किया आपको. ओके
ओके ओके
या, आर यू गेटिंग? Very simple. Now undo this. Okay, this is what the normal, and next thing is what, suppose I would like to, okay, see, this grid system is at the origin. This grid system is what, at the origin. Now I have to shift it at a distance of 5 meter in x direction. So how I can do that? Very simple. Go to edit stories and grid system, go to second one, go to modify and show grid system, and in x direction I would like to shift it by 5 meter, and let's say simply okay, and let's say simply okay. Once you click over the okay, as you can see here, it is shifted by 5 meter in x direction. It is what, shifted by 5 meter in x direction. Now suppose I would like to shift it by 5 meter on y axis. Also go to edit stories and grid system, go to second one, go to modify and show grid, and I would like to shift it by 5 meter and change it to what, make it as 0. Okay, let's say simply okay, and let's say simply okay. This is done. Now next I would like to rotate it by what, 30 degree. I would like to rotate it by 30 degree. Like this I would like to have my grid rotated by like 30 or 45, whatever. Suppose let's say 45 degree. So how I can do that? So go to editor, go to edit stories and grid system, go with the second option, go to modify, and rotation make it to be 45 degree, and let's say simply okay, and let's say simply okay. Let's see. Hello, are you getting my point or not?
Yes, sir.
Yes,
So
sir,
that
yes.
is the thing. Wong sir, is that all okay?
Okay, sir.
Very good. So this is all done. Mubashira, is that all okay? Clear?
Yes, sir. Yes.
Okay. Now this is the way how you can prepare the like cylindrical grid system in the like ETABS software first. Now second and the last one, for the ETABS quick template option, this grid I have to prepare, and you all will have to guide me to prepare this grid. I will not going to prepare it. Just tell me. You all have right to unmute, and you have a right to give the answer and give the suggestion, but take care your background noise should be not be there, so that otherwise it is going to create the problem to the others. Okay, now tell me what is this? Either it is Cartesian form or cylindrical form. What kind of grid system it is? Fast, and don't take much time. Fast.
It's Cartesian and cylindrical. Both.
There
Cartesian
are two
both.
systems.
It's both.
Very good.
It's
So
both.
it is both. It is Cartesian form, it's cylindrical form. Very good. Now come back. Let me initiate the new project. Go to file, go to new model, and once you click over the new model, say simply no. I don't want to save this. It is asking to save. So say no. Now we have to go with this second option. Now here the most important thing we have to decide, because every time we will do, means mostly we are doing the Indian project, so we don't need to worry about this. Let it to be as it is. What about this? So you need to look your plan. So whether it is metric SI or in feet and inches, tell me.
It's metric.
Very good. Just go back and
It's
go to your
metric.
ETABS. Metric SI, let it to be, let's say simply okay. And as you told me, as you have said, it is what cylindrical and Cartesian both. So how to proceed? Just tell me idea बताइए कैसे proceed करेंगे fast. बताइए. अभी cylindrical भी है, Cartesian भी है. क्या करूँ मैं?
Go
सर
for
पहले
the
कार्टेशियन
One by
सर
one.
पहले कार्टेशियन का कर लीजिए, फिर उसके बाद सिलिंड्रिकल का कर लीजिए.
Okay. Stop. Next. Fast.
Go for the Cartesian and then do the cylindrical.
Okay, very good. Then next, Mubashira. What are you saying?
Yes, sir. Go first Cartesian and second cylindrical.
Very good. Then anyone else?
So we will go for the Cartesian, then cylindrical, then system origin. We will change that origin
Exactly. Very good.
to
Okay.
variable.
Good.
सर 2 ग्रुप बनाएंगे G1 G2 करके.
Exactly. Okay. So
फिर-
जीवन तो ऑलरेडी आपका वहां पर होता है, राइट?
हाँ, तो G2 और बनाएंगे और उसका सेट वो दे देंगे कोऑर्डिनेट.
ठीक है. सो पहले कार्टेशियन करेंगे, फिर सेकंड हम लोग उसी में ऐड करेंगे, राइट?
जी जी.
Okay. Now, so come back. So just follow me what I am doing. If I am doing wrong, then let me know. See, number of grids in X direction. Now here the label is not there. We are moving fast. So how many number of grids are there in X direction? Tell me.
8.
Sorry.
8, sir.
8.
Very good.
Eight.
8 numbers are there. Very good. You all have a right to answer and give the suggestion and any instruction. Okay. 8. In Y.
4.
4.
Okay. Go back and put it here as 4. Then spacing of grids in X direction, whether it is uniform and non-uniform. That is our
Non-uniform.
It is non-uniform. So there will be use of this uniform or not? Why I am doing this if it is non-uniform? We
Go
have-
first uniform, then second non-uniform.
Okay, very good. We will take the help of uniform grid system, right? So our work will be easy. So here what we need to see in the spacing? Typical spacing, right? Is
Yes.
there any typical spacing in X direction? Tell me.
No, sir.
No.
No.
Any typical spacing in Y direction?
No.
No.
No. So what I can do? I think we let it to be as it is. Let it to be 8 and 8. No problem, right? Go to custom. Go to edit grid data in spacing. Now two options are there: grid data as ordinate, grid data as spacing. With which option you would like to go?
Second.
Spacing.
Very
Grid
good.
data.
Go with this spacing. Now tell me here. Okay.
A is 0.
No, wrong.
No.
A to B. Here it is becoming what? A. I am considering what? It is I. So A to B in difference of A, it is what?
5.9.
5.9.
5.9. So put it here as 5.9.
Sir,
Yes.
if I go to the please show the model, please.
Let us see.
If we go for the n is 0, then it will be all okay.
No.
We started from
No, it will not be 0. That is the way of, that is the what for option of this first. Grid data as ordinate. Means you are going to set first grid as origin, first grid as at base. And first grid you are going to take as a reference. Right? That is the case of first option. See, I am getting a first option. So here it is become first will be always 0. Like that. Okay.
okay.
And in the second option, the last will be at the 0. In this first option, first will be at the 0. And in the second option, last will be at the 0. But if you are going to work with this second option, so you don't need to add 1 and 1, 1 and 1, 1 and 1. You don't need to do that. Adding. But in display ordinate as spacing option, you have to just see how much the distance between two grid, and directly you have to put that. So this one is the easy, as means easier than that of the first one. Got it? We have seen the problems in the last session, right? Hello.
Yes, sir.
Yes.
Yeah, good, very good. Now come back. See, here it is what? Here it is 10.2, 9.6, 5.3. 10.2,
9.6.
9.6, 5.3.
3.
Very good. 5.3, 6.2, 9.1, 3.9. 6.2, 9.3,
1.
1. 9.1.
9.1, and
6.2.
wait,
3.9.
3.9. Yeah, it is what?
3.9.
3.9. Getting? Now next here it is what?
4.9.
4.9, 5.8.
4.6.
4.9, 5.8, and
4.6.
4.6. Good, very good. 4.6. So this is all done, and here we are smartly, means in advance we are working. I'm going to change the color to red one, just for your visibility. Okay, for your better understanding, I'm taking red. Otherwise, by normal practice, we are not going to change this color by from gray, because gray is the most suitable color. But yeah, but for your understanding only, I'm taking this. So let's say okay, and let the bubbles also as 1250. If you like to change, you can change that, you know very well. Let's say simply okay. So in plant definition we have completed. Over the height,
Sir, we'll
it
change
is
the
not,
grid name.
sorry.
Grid name also we can change it also.
Yeah, grid name you also can change, your choice. Okay, if you like to give any name, you can put that here, grid ID. Okay,
Okay.
let's say
Okay.
simply okay. And here we are not going to talk about the over the height modification. Let it to be, I will talk in detail about this later. Okay, just see grids, we have to check this grid. Let's say simply okay. Once you click towards the okay, now the grid is available. Yeah, in this way we have completed this Cartesian form. Now we have to add a new grid as a cylindrical. We have to add a new grid as a cylindrical. Okay, so simple. What? Just go to editor, go to simple this editor, and in editor, uh, go to edit stories and grid system. Okay, can anyone guide me how I can do that? First, edit, then
Edit story.
edit stories and grid system. Okay,
Yeah, add the new
Add
grid
new
system.
systems.
don't say, others are not allowed to say anything. Modify and show grid system. Okay, then
Add new system.
sorry, add a
It's
new
add
system.
new,
Okay,
new
then
system. Cylindrical, select.
cylindrical. Okay, then
At
And
first, we
then
need to find the center point
find
location.
the center point, the origin.
center point will be what? Origin.
You have to go back to the plan.
Okay, okay. First let it to be 0 0. Don't change it. First let it to be
Yeah.
0 0. Just tell me to complete this first. Okay, tell me how many number of grids will be in radial direction.
6.
One, center,
Three,
second, third,
6.
fourth, fifth, sixth. Go back and put here in radial direction as 6. In tangential direction, how many it is? See, angle between these, it is 18 degree. It is what? 18 degree. Tell me now.
11.
11 number. Okay. How you have calculated? So 180 divided
Divide
by
by 18
18
plus 1.
plus 1. Okay. So it is going to become what?
11.
11. 11 number it is becoming. So I am going to put here as 11. 11. Now
Yeah.
spacing of grids in
हो जाएगा एक बार फिर से बोल देंगे
क्या?
180 by 18 plus 1
180 by 80.
plus 1
Okay. The angle between these two tangential lines are 18 degree. Okay. So to calculate the number of tangential line, what is the formula? Total angle divided by angle between two tangential line, that will be what? 18 plus 1. So how much it will become? Like 10 plus 1. So it is going to become what? 11. It is going to become what? 11. So I'm going to put here as what? 11 number. Now spacing of grids in radial direction. How many number of spacings? Spacing of grids in radial direction. So how much it is? It is 2 meter.
2
Okay.
meters.
So I'm going to put here as 2 meter. Now spacing of grids in tangential direction. So you know that it is what? 18. It is what? 18. So this
18.
is all done. So what I'm going to say? Simply okay. and let's say simply okay. Once you click over the okay, so your grid is now available. Your grid is now available. Is it visible or not?
Yes.
Very light. So now go to editor, go to edit stories and grid system, and go to second grid. Just go to modify and change the color to this blue color, and let's say simply okay, and say okay, say okay. Then see, this is what the red one is your Cartesian one, and this cylindrical one is your blue grid. Tell me, this one is the right one as per your exercise, as per your question.
No.
No.
What is the problem?
We have to change
Origin
the.
पर है.
It is what at the origin. Then what we have to put it at this point. So how you can do that? So basically, if I am considering it is what 0 0. Basically, if I am considering it as 0 0. So go back and let's check it is at 0 0 or not. Yeah, it is at 0 0. So this point is actually 0 0. So in reference of this origin, what we need to do? We need to calculate this x distance and this y distance. That is right. So how I can calculate that? So total length you can measure, okay, by adding these all distances and subtract, means subtract this with this value, this distance. So first add these values: 5.9, 10.2, 9.6, 5.3, 6.2, 9.1, 3.9. Let me know the addition of all these.
No, the point of origin is actually 35.
Just tell me what is the addition of these all distances. Simply. Hello.
50.2.
60.2. Very good. It is what 60.2 minus
50.2.
this
Sir,
distance
50.
2 meter, 2 meter, 2, or this total is what
50.2.
10. So it is becoming what?
50.2, not 60, 50,
It is
50.2.
50.2. Okay. 50.2 minus 10.
40.2.
Very simple. 40.2.
40.2.
40.2. And then this x is now okay. For y it's total this addition 4.9, 5.8, 4.6. Total addition will be what?
15.3.
Sorry,
15.3.
15.3 it is. Okay, so put this all, go back and go to this software and go to editor and go to edit and storage grid system. For the second grid system, go to modify and show grid, and for these distances, x is what actually 40.2. It is 40.2, and y is what
15.3.
15.3. I'm going to put it let's say simply okay. Now see, your grid is now shifted to this point. Is that all okay? Hello.
Okay.
Sir, can
Yes,
you
sir.
repeat that, please?
Yes.
Okay, I will repeat it once more. Undo this. This is what at the center. We have x distance is what 40.2, and y is what 15.3. So for cylindrical grid we have to change it. So go to edit grid system, and for the second grid, modify and show grid system, and global x axis we have to put as 40.2, and for y it is what
15.3.
15.3, and let's say simply okay, and then again say okay. So that will be shifted to this point. So now it is Cartesian and cylindrical will be merged like this, so that this problem will be what clearly solved. Got it?
Yes, sir.
Yes, sir.
Okay.
Yes, sir.
So this is what the last example to understand your cylindrical, Cartesian, and how to go with this ETABS quick template option. Got it? So this is the second method we have completed. We have seen offset point method. Why I have not discussed much about the offset point? Because I told you in the last session also, there is not much means use of that method. Just for your understanding, just for your knowledge, I have shared that. But basically, this second and third option is in use. Got it? Hello.
Yes,
Yes,
sir.
sir.
Okay.
Yes, sir.
Yeah. Then go to clear this all, come back. And now the third method is what? Export and import method of preparing the grid lines in your ETABS software. So first take the example, go to grids, go to RK center line, import and export practice, just click over that. Yes, is it visible?
Yes, sir.
Okay. So suppose what is the flow of completion of any project? You will get the architecture plan. Over the architecture plan, you have to position the column, beam, and beam layout. You have to prepare, and then finally you have to prepare the structural framing plan, or we are calling it as what? Beam layout. So once the beam layout gets completed, then we have to prepare the center line plan, and after that, doing all those things, we are getting what? The final center line plan. Final center line plan we are getting. So how to do that framing plan and how to prepare a center line, that is all the later discussion, that all the part of our second section of this training program. But here and we have to understand how you can prepare the grids in the software itself, how you can prepare the how you can prepare the grids in the ETABS CAD, and then how you can import in the ETABS software, how you can prepare in CAD, then how you can prepare in ETABS, how you can import in ETABS software. Got it? So it is actually very simple. For this also you can proceed for ETABS quick template option. This is not much the complication. There is no complication. We are not going to call this this is the complicated center line plan. Let me show you which one is the complicated. Tell me. Let me show you. Wait. I think demo I think it is available. See, for this building we are going to call it is complicated. See, tell me, it is complicated or not? How you will prepare the grid? Tell me, is it possible to prepare grid here for this in ETABS
No,
software?
No, sir.
no.
Okay, even this is also going to, I am going to call it as easy and simple. Now come to this another one. See this one. Tell me, it is easiest one or complicated one? Will you able to prepare the grids for this building or for this structure in the ETABS software? Tell me, the geometry. See the geometry. Is it possible? Actually, you don't know because you have not worked for this kind of project. But it is not possible to prepare the grids for this in ETABS software itself. You have to prepare the grids in the in this CAD by center line plan, and then you have to import that in the ETABS software. If you are trying to prepare the grids in the ETABS software by these methods that we have completed as a ETABS quick template, you will not be able to complete it. Are you getting? Hello.
Yes, sir.
Yes, sir.
Yeah. So
Yes,
for
sir.
this kind of architecture plan, I'm saying what? It is the complicated one. But yeah, for this also we are going to say it is the complicated because just we have to understand the method. Okay. So suppose this is a center line plan. So if I'm saying what, just go with the ETABS quick template option. So you have to make the grids in this software, and accordingly you have to prepare the grid lines in the ETABS software. But what I'm saying, don't use the ETABS quick template option. Don't use the ETABS quick templates to prepare the grid lines. Just export this and import this center lines in the software directly. So how you can do that? So let me show you. Just follow me and try to understand what I'm saying. So very simple. First, open a new CAD file. Open a new CAD file. The process is what? first we have to export the plan or center line plan from the CAD, and that exported file we have to import in this ETABS software. Just have to export and then have to import. Simple. But in between of these two action, what important things, what steps you have to take, that you need to understand. So first open a CAD, and then in this CAD again go back to that center line plan and select this complete plan, and let okay, just say control C. You have to copy the things from here. You all I hope that you all will aware with this CAD and practicing how to practice with this CAD. So select this all thing and say simply control C. Coming back to this, and then say simply say control V. Okay, this is all done. Now randomly don't put it anywhere. Randomly don't put it anywhere. Let it to be as it is. Now just put 0, comma 0. I would like to keep this grid line at the origin. I would like to have this grid line at the origin. What is the use of this? I will let you know later. Now put 0, 0 and let's just simply enter. So your grid line will come to the origin. Up to this level, it's all clear. Hello.
Yes, sir.
Yes, sir.
Yes, sir.
Okay, very good. Now, next most important thing, you have to save this file not in CAD. You have to save this file in DXF file format. Okay, so go to this and go to save as, and go to desktop and okay, go to your folder, your bash folder, and bash 9, and here I would like to create as DXF CAD. Rename it DXF CAD. Okay, now just open this, and here I would like to save see the file format is what? DWG, start.dwg. So change it to what? DXF. Change it to DXF. Now save this file as 001 title, and say simply save this file. Okay, now this is all done with the CAD. First you have to export, then you have to set at the origin 00. Sorry, you have to open a new CAD file, then you have to copy the file, copy the center line plan from the base file. You have to put it in the new file, being your positioning as 00. Got it? And you have to save this file in the DWG format, right?
Correct.
EXF format.
Yes, in DXF format, not in DWG. Mubashira, hello.
Sir.
Okay.
Okay, now then this is all done. Now close it. So it is asking to save in DWG again. Okay, let it to be saved this again DWG also 00 DWG, but our means file that will be in use, that is what? DXF that we did. Okay, now come back to your ETABS. Now your work will start with ETABS. Go to file, go to new model, and say no. Say no. This is all done. We have to go with this third option and let it to be metric SI. This is all done. First check your unit. What is the unit? Unit is what? Change it to check it.
Metric.
3.3. It is what? Metric. So go back and check it metric. Let's say simply okay. Now you have to say give the answer. Tell me, either we have to check blank or we have to go with grids. What we need to do?
Blank.
Blank.
Very good. So go to blank. We are not focusing to the story definition. Let it to be. We will talk it later. Go to blank and let's say simply okay, because we don't need to have anything here with the help of the software. It will be what? Blank. Two windows will window will be there. One is plan, another one is your 3D view. But see how many levels are there? 1, 2, 3, 4. How many levels?
4.
4 levels are there. Keep in mind. Just go to file, go to import. Two options are there. If you want to take anything outside of these ETABS, so the export option will be there. If you want to take anything from outside to this ETAB, inside of this ETAB, so go with import. Is that all okay?
Yes.
Okay. Go to import, and here DXF file floor plan. Is that all okay?
Yes, sir.
Okay.
Yeah. Then click over that. and it is asking the file where your file is actually saved. So go back and where it is, I think, yeah, bash, no, I think, okay. Now your file is now available. See, it is not reading the DWG file. Actually, DWG also available here, but it is not considering that. Getting? So DXF file only. So check this DXF and let's just simply okay. Open. Once you click over the open, see, one more thing I missed to uh, say that. See, your grid layer is what? Which one is your grid level? This, it is what? Center line. Keep in mind. Okay. So go back to this and change it to what? Beam. These all lines I am going to say these are the beams. What to do for that? That is the later discussion. So I am going to say what? Beam. So check this center line as a beam. Got it? I'm not going to check the column. So simply what? You can also import the column position also. You can import the slab also. But that is what? At the advanced level. That is what? At the advanced level. You can do everything in the CAD. You can directly import that all things in the ETABS software directly. Positioning of column. So your work in the ETABS software will be less. But at initial level, understand this much only. Okay? Hello?
Okay.
Yes, sir.
Okay. Yeah. Center line as a beam. This is done. And unit is
वो
what?
बाद में आप दिखाओगे ना?
हाँ हाँ बता देंगे वो आप खुद ही कर लेंगे इतना आगे मैं आपको लेके चले जाऊंगा. Okay?
अच्छा अच्छा.
Yes. Now, file unit is what? Either it is mm or meter or feet or inches, centimeter. What it is actually?
Meter.
Very good, meter. Now, these are the properties, but let it to be as it is. Don't worry about that. And see, story level. At what level you want to import your plan? Either at first level, either at second level, third level, fourth level. कहाँ पर आप import करना चाहते हो बताइए.
One.
Hello.
Story 1.
One में.
Story 1.
Okay, your choice. Story 1. Global up direction means, as I told you in the last session, see here also. Here it is what? Here, here it is X, here it is Y, and over the height, it is considering Z axis. So yeah, over the height it is Z. Let's say this is what I can say, what I can say, margin I can say. It is what? Up to this level, it is going to consider. Okay, let's say simply okay. Means
Ignore
it is
lines
what?
shorter than वो क्या है?
Sorry?
वो क्या चीज़ है? Ignore lines shorter than.
एक्चुअली ये अलाउंस है. अगर कोई लाइन बाय मिस्टेक आपने कैड में बाय मिस्टेक बन गया है वो और उसका डिस्टेंस कितना है 1 mm से कम है तो उसको इग्नोर 1 mm तक के है 1 mm से कम है उसको इग्नोर कर देगा.
अच्छा.
ओके सो वो है. लेट्स से सिंपली ओके and it is asking to first save your file. So go to this and delete folder. Anywhere you can save this. Make it as 001. Save this. Save this. See, in 3D view it is in visibility. But in plan view, go to plan, come to story first. Let's just simply apply. See, now close it. See here how smartly you have imported the complete. If you are going to do all this thing in the ETABS software itself, so tell me, in this short time, will you able to create this thing?
No.
No.
It's not possible.
Are you getting? So that is the power of this third option, export and import method of preparing the grids. Actually, it is with this option we are directly coming to next step. एक्चुअली ग्रिड बनाने के बाद क्या होता है फ्रेमिंग करते हैं हम लोग तो वही चीज हम लोग डायरेक्ट कैड से फ्रेमिंग करके एक स्टेप आगे और आ जाते हैं हम लोग. आप कहेंगे सर यहाँ पर ग्रिड कहाँ पर है आप इसको ग्रिड कैसे कह रहे हो. एम आई राइट और रॉन्ग?
यस सर.
सो ये एक्चुअली ग्रिड के बाद ऑटोमेटिकली आप एक स्टेप आगे चले आए हो. आर यू गेटिंग? या. सो दिस इज द वे हाउ यू कैन प्रिपेयर द grid lines or center line, how you can import directly the center line. Okay, this is the way. But this is not the end. You have to cross verify whether your imported file is right or wrong. Okay, so what we have measured here, the distance between these two lines is what, 3.34. So let's check whether we have imported the right thing or not. So go to this draw dimension line, draw dimension line. Once you click over that, now close this. From this point to freely move to this point, and let me see, let me know how much it is. 3.34. And how much it is? 3.34. So is it right or wrong?
Correct.
So first
Right.
cross check it. First cross check, because if you are doing the mistake with the modeling or preparing the center line, so what I told you in the last session, your analysis wrong, your design wrong, your scheduling wrong, your detailing wrong, everything will be what? Wrong if your model is wrong. Understood?
Yes.
अच्छा सर, अगर इधर गलत निकला तो क्या करना चाहिए?
देखिए कहाँ मिस्टेक किया है आपने, वापस से उसको करेक्ट करिए.
मतलब मॉडल में अगर 3.34 ही दिखा रहा था, अगर इधर में वो दिखाया 4 या समथिंग,
हाँ, तो आपने कहीं मिस्टेक किया है. फाइंड करिए कहाँ मिस्टेक किया आपने.
मतलब फिर से पूरा करना पड़ेगा.
Obviously.
ओके सर.
Okay, so this is what the first part of this first section is now completed about the understanding of the grid lines, how to prepare the grid lines in the ETABS software. All that three methods I have covered. Now next part of this training we are going to start. Everything for the practice I will share. Is there any doubt and question to anyone? Tell me. Till that I'm.
अच्छा सर, ये सब बड़ा बड़ा जो प्रोजेक्ट होता है, ठीक है, उसमें से सेंटर लाइन कैसे निकाले?
वो सब आगे का डिस्कशन है, सब आगे का. ठीक है, सब आगे की चीजें डिस्कशन है. What you have not understand, I mean, so you are not getting from the topic till now which is covered. Tell me about that only. Now the new exercise we are going to start, that is what? Validation of ETABS software. Validation of ETABS software. So what does mean by the validation? So as I told you, software is just a software. If you are giving the wrong input, software will give you wrong output. If you are giving the right input, software will give you right output. Software actually should give the right output. If you are giving the wrong input, obviously you will get the wrong output. But if you are giving right input and software is giving wrong or wrong output, then you have to check it why software is doing the mistake. And if you are giving the right, like suppose wrong input, so software will give the result. So you should have a command to check the software, like where you did the mistake. That's why you are getting the wrong output. Suppose a simply supported beam is there. Suppose one beam is there, which is what simply supported, and we know that what is the formula at the mid of this beam. So WL is square by 8. This is the formula for the simply supported beam. So we know that suppose the answer should come as 100. But when you are going to see the result from the ETABS software is giving the result as what? Suppose 120 kilonewton meter. So you should have the knowledge and idea why software is giving this wrong result. Why software is doing the wrong result. So you have to check whether you have done everything as right or wrong. You have to check yourself first. Then if you are right, then you have to check in the software why software is giving the wrong output. Is there any problem in the software? Is there any problem in my definition? In any difference between my consideration and software consideration? Sometimes software is 100% right and you are 100% right, but still there is a difference between the result. Then you need to know what is the difference in the your consideration and software consideration. Okay, every time your manual calculation will not match with the software result, because software algorithm will be different and your consideration will be different, because your software is working on the FEM basis, finite element basis concept it is working, and our our approach for the design and performing the analysis is different. That is what the conventional one. So obviously the result differences will be there, but up to what extent the differences are allowed, and means at what points, at what level, up to what level the we should not allow the difference. We should try to get exact 100% result. So that's all called as what? Validation of your software. Is that all okay?
Okay.
Yes, sir.
Yeah. So in this step, in this exercise, this is the second part. So of first section, that is what? Validation of software. But with this exercise, with this title, there is not only the objective. Along with that, we have to learn so many things. That will be what? Along with this exercise, you will come to know how to assign the loads, point load, uniformly distributed load, UVL, uniformly varying load, how to see the forces in the members, what are the access systems, and how to perform the analysis, how to see the means animated shape of the structure. Okay, so many things we have to learn along with this exercise. So this is not only the validation. Here we are going to learn so many things. What are the different types of elements in the ETABS software? Okay, so that all we have to learn. So after the completion of this exercise, you will come to you will become more familiar with the software. You will be what? Next level of understanding the software. Getting? So very first thing, uh, what are the different types of access system? What are the different types of access system? Can anyone tell me what are the different types of access system? So actually there are three types of access system. One is your global access system, second one is local access system, and third one is your national access system. So three access systems are there. What's their role? What is their definition? What's their importance? See. Okay, is it visible?
Yes, sir.
Yes, sir.
So there are basically three access systems. One is your global access system. Another one is what? A local access system. Okay, global access system. What does mean by global access system? The access system which is representing the entire model, or that is representing all the elements in the complete model, that is called as what? Global access system. Again, once more, the access system which is representing your entire structure, your entire model, called as what? Global access system. Okay, so see, here it is what? Called as what? Global access system. So basically see, this is one model, this is what? One model, this is what? One model, means this is what? Totally one model. And here it is what? Suppose it is column, it is what? Column, this column, these are the elements. These are one type of object. One type of object is what? Here three types of objects are in this model. One is your column, second one is your beam, and third one over this is your slab. Three objects are there. So all the beams which is running in this direction, which is we are going to call it as what? Along x. All the beams which is running along this direction, this dimension, this length is defining along the y direction. All the elements which is along the this vertical line, along the z, we are going to call it as what? Along the z direction. So here the column may be, here the column, suppose there any other element is there which is along z axis. So I'm going to call this element is also along the z. So whatever the things are there which is along any particular direction, we are going to call it as what? It is along X, it is along Y, it is along Z, because this axis system is representing your entire model. Is that all okay?
Yes, sir.
Yes, yes.
So all the things which is in this direction, we are going to call it as what? Along X. All the things of your model which is along this direction, we are going to call it as along Y. It may be beam, it may be dimension of your slab, it may be anything. All the things which is along this line about vertical, we are going to say it is what? Along Z. So it is representing your entire model as global axis. Got it? Now, why we need to have this three axis to define this entire model? Because it is three-dimensional model. It is a solid element. Sorry, it is solid object. So to define any solid object, obviously you need to have what? Three axes. Right or wrong?
Right.
Any. Now my question to all of you is that, tell me, if I'm asking about this particular beam, so this beam is what? It is solid element, or it is what? Line element, or it is what? Area element.
Line element.
Line element तो है वो, but it is solid or not? It is having its
Solid.
three dimension or not?
Solid.
Hello?
Solid.
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 Okay. So beam का भी three dimension रहेगा कि नहीं?
रहेगा.
बीम का भी उसका खुद का थ्री डायमेंशन रहेगा. बीम इज हैविंग इट्स लेंथ, बीम इज हैविंग इट्स विड्थ, बीम इज हैविंग इट्स डेप्थ. तो अगर मुझको स्पेशली ये बीम को एक्सिस से शो करना है, सो आई नीड टू हैव वन मोर एक्सिस सिस्टम that will define the length along this direction, depth of this beam is along this direction, and this along width, it is what? Third dimension. It is X, it is Y, it is Z. Hello?
Yes, yes.
But if I am taking X, Y, Z, so clashing of this global axis and local axis will be there. Clashing. So that's why I am going to say it is as 1, 1, it is as 2, 2, it is as 3, 3. Will it be okay?
Yes.
So in a particular model, each individual element will also be a solid element, and to define all the dimension of this particular solid element, we need to have one another axis system, and that axis system we are going to call it as what? Local axis system. Understood or not?
Yes.
Because
Yes, sir.
entire model we are going to see as a one. Now we are going to give we are coming inside of this model and considering one element. And if I am taking beam, so it is what? Let me show you. See, then column is also what? It is having its own axis system. Beam is also having its own axis system. Slab is also three-dimensional element. It is having length, width, and depth, means thickness. So it is what? It is having its own like axis system. So global, first is global, second one is what? Local axis system, to define the axis or dimensions of a particular object. Okay, but come one step more inside of your particular element. You can take column, you can take beam, you can take a slab. So let's consider beam. So beam is made up of what? Beam is made up of solid particles. Beam is actually made up of solid particles. So this solid particle is also having is also a solid element. This particle is also solid element, and it's also having its three dimension. So define its three dimension, we need to have further axis system. Am I right?
Yes,
Yes.
sir.
So this we are going to call it as natural axis system. Is that all okay? Hello?
Okay.
Yes.
Okay. So
Okay.
three axis systems are there. One is your global, second one is your local, and third one is your natural axis system. Now come to the software and try to understand. So basically,
सर नेचुरल
Sorry?
एक्सिस एक बार सर फिर बताना नेचुरल.
अच्छा, ओके ओके. क्या है, पहले हम लोगों ने पूरा मॉडल देखा. पूरा मॉडल को आपको एक एक्सेस सिस्टम से डिफाइन करना था, तो हमने ग्लोबल कहा. फिर उसमें एक स्टेप हम लोग और अंदर गए, तो अब एक एक एलिमेंट को हम लोग देख रहे हैं. एलिमेंट मीन्स बीम, कॉलम, स्लैब. अब बीम का खुद का लेंथ है, खुद का विड्थ है, खुद का डेप्थ है, तो आप उसको कैसे शो करेंगे? सो उसके लिए हम लोगों ने लोकल एक्सिस कहा कि वो एक एक्सिस जो है वो सिर्फ एक ही एलिमेंट को, एक ही मेंबर को डिफाइन करता है, सो कॉल्ड एज लोकल एक्सिस। फिर उसके अंदर और एक स्टेप अंदर गए तो हम लोगों ने देखा ये बीम जो है वो सॉलिड पार्टिकल से बना हुआ है। सो ये सॉलिड पार्टिकल भी सॉलिड है, इसका खुद का, अगर मैं एक, ये ठीक आपको सर्कल दिख रहा है, अगर मैं इसको इस तरीके से लूं, एक सॉलिड एलिमेंट, राइट? सो ये बीम आपका स्मॉल 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 सॉलिड पार्टिकल से मिलकर ही आपका एक पर्टिकुलर मेंबर बनेगा। एम आई राइट और रॉन्ग?
Right.
ओके, तो ये सॉलिड पार्टिकल्स का खुद का एक्सेस चाहिए इसको डिफाइन करने के लिए, बिकॉज देयर आर सो मेनी नंबर ऑफ सॉलिड पार्टिकल्स। कुछ इस तरीके से होंगे, कोई छोटा होगा, कोई बड़ा होगा। ओके, सो उसके लिए क्या है, हम लोग इसका खुद का एक एक्सेस सिस्टम चाहिए, एंड दैट वी आर गोइंग टू कॉल इट एज नेचुरल एक्सेस सिस्टम। अंडरस्टूड? समझ में आ गया?
Yes, sir.
Yes,
Yes,
sir.
sir.
ओके, गुड।
Yes, sir.
अभी सॉफ्टवेयर में क्या है, हम लोग नेचुरल तो नहीं देखेंगे, कुछ R&D वर्क वगैरह आप कर रहे हो, रिसर्च वर्क कर रहे हो, सो तब आपको लगेगा। नॉर्मली ये नेचुरली तो हम लोग की जरूरत नहीं है। हाँ, हम लोगों का मेन फोकस है ग्लोबल एंड हेलो
Local.
लोकल। अभी सॉफ्टवेयर में कैसे देखेंगे ग्लोबल एंड लोकल? सो गो टू यूर सॉफ्टवेयर एंड मैंने एक मॉडल लिया है, सो ये एक्सिस सिस्टम। अब आप बताइए ये ग्लोबल है कि लोकल है?
Global.
ग्लोबल।
Global.
सो अब जितने भी बीम है इस डायरेक्शन में रन हो रहे हैं, सारे बीम्स वो अलोंग एक्स है, सारे एलिमेंट्स इस डायरेक्शन में, दैट इज व्हाट अलोंग वाई, सारे एलिमेंट जो इस डायरेक्शन में है दैट इज व्हाट अलोंग जेड। सो इट इज व्हाट ग्लोबल एक्सिस। बट आई वुड लाइक टू सी द लोकल एक्सिस। सो हाउ टू सी द लोकल एक्सिस? एक्चुअली हाउ टू सी, डोंट वरी अबाउट दैट, जस्ट सी कैसा दिखेगा आपको साइन में लोकल एक्सिस। ठीक है, ये देखिए अब लोकल एक्सिस आ गया आपका पूरा, दिख रहा है? हेलो,
Yes, sir.
Yes, sir. दिख रहा है.
it is what your local axis for the column, local axis for the beam. If you want to see local axis for the slab, go to this, I will let you know कैसे देखना है। अभी ये मत पूछना आप, मैं सब चीजें बताऊंगा आपको बाद में, ठीक है? ओके, ठीक है, देखिए लोकल एक्सिस भी दिख रहा है आपको यहाँ पर, लोकल एक्सिस। हेलो,
Yes, sir.
ये स्लैब का लोकल एक्सिस, पहले हमने देखा था बीम का लोकल एक्सिस। ओके, एट ए टाइम आप सारे भी देख सकते हो। गो टू दिस, अप्लाई, सी beam, slab, column, every local axis. Natural axis is not possible to see, and that is not needed to see actually. Okay, so now your global and your local is more than enough. Is that all okay?
Okay, sir.
So this is the thing that we have covered today. Okay, hello.
Yes, sir.
Yes, sir.
Yes, sir.
So now by tomorrow we will start next important things, and we will start this exercise from beginning, and we are trying to understand so many things more. Okay.